right, everyone? Ready to go? Okay. Yeah, so welcome everybody to this last slot of Monday at Spring 1 2013. My name is Oliver Gierke. I work for Pivotal these days. I'm an engineer in the Spring Data team, actually, leading the core and JPA Mongo modules, taking care of the release train that we've just announced today. And I'm also a member of the JPA expert group, so in case you have questions in terms of database related stuff, a bit of that we will go into in this talk as well, but just feel free to come to me and ask me stuff. What is this session all about? I've claimed it Spring RESTBucks, a hypermedia-driven REST web service. Okay, let's skip that one. And the session is, I've held the session in a variety of ways. I've done 60-minute talks on that, and then felt, okay, this is a topic I'd like to get into a bit deeper. Turned everything into an 8-hour training regarding RESTBucks, and it's essentially the material that you see here shrunken down into 90 minutes again. So there's quite a lot of stuff, and we'll probably not be able to go into too much detail in everything. But the essential idea is that with Spring RESTBucks that I'll introduce to you in a second, I've written a reference application that builds a REST web service, a hypermedia-driven web service, REST web service, using Spring technologies, using a variety of Spring technologies, which you could possibly spend 90 minutes on discussing each of them separately. But I thought it might be interesting for you to see, okay, how this stuff works together and how the individual modules link into each other and provide benefit that's more just the sum of 3 separate projects, as we will see. So what I would like to do is just show you Spring RESTBucks, what it is, what it does, like the features. We will run the application. I'll show you a bit of the stuff working live. And what I'd then like to do, we have an architectural diagram, and it consists of 4 major pieces. And what I would like to do then is just step with you into the code of these 4 major pieces and introduce the technically building blocks to it and some design decisions that I've made, some implementation details and stuff. So pretty much everything that you could go ahead and maybe this evening, go clone the GitHub repo and have a look at and find yourself vaguely familiar with the code base and know what's going on, right? The code samples for this session is the Spring RESTBucks projects. I'll show you the GitHub URL in a second. And there's also 4 different projects in my GitHub repo that have the individual steps, like 4 dedicated steps on building the app, not really from scratch, but adding the relevant bits and pieces and some to-dos in there so that you could maybe even go ahead and at home try to rebuild the app with some guidance from the slides and just explore the different modules or technologies that we're going to use. So we're about to start with a bit of Spring Data. So has anyone heard of Spring Data already? Quite cool. Repositories, Spring Data repositories. Okay, so I probably can move a bit quicker through that part because the hopefully more interesting part is there we go. Is the REST side of things. So I'll introduce or show the Spring Data REST project to you, which part of the app that we build it will implement, and briefly show you how you do integration testing of REST web services these days. And we conclude the talk with the implementation of a complex business workflow using hypermedia elements. I will go into the workflow and how that works and how we model and design it up front in the first part of the session, and you see, okay, how everything works together and how that stuff one hands into the other part in the last bit of the session, right? Seeing quite a lot of code. All right, so RESTBucks. What is RESTBucks, right? We have Spring RESTBucks. Okay, that seems to be something Spring related, but what is this RESTBucks kind of thing? Has any one of you, before I ask who has read the book. Who of you has attended the sessions of Ben Hale this morning? Yeah, one of them or two of them. I just had a brief look at the slides, and they seem to cover a lot of the basic ground. So what I'm assuming here, I really briefly rushed through the basic concepts of REST, like resources, URIs, and stuff later on. But we'll concentrate on the more advanced stuff. So what is hypermedia? How do links work? What is a hypermedia-based media type, and stuff like that. A book that I can recommend reading up on all that kind of stuff is Rest in Practice, written by Ian Robinson and Jim Weber, and a guy whose name I can never really pronounce correctly, Savas Parastadidis, whatever. He hopefully will excuse me on that one. It's a really, really good book to, once you got, okay, this is there are HTTP verbs and you have to use them correctly. Once you got that, if you want to go into, okay, how do I actually model complex business processes in a REST world, right? And the core of the book is an example they call RESTBucks, which is a model or an idealized model of the way you order coffee at Starbucks. That's where the name comes from. It's not really 100% or not a 100% identical model to what that really looks like in Starbucks, but it's neat in terms of that it's not as simple, so dumbly simple, right? But it still contains some aspects of a REST web service that you are very likely to run into when you're modeling your own ones. So triggering long-running background processes, or constraints on state transitions of your resources and stuff like that. So, as you probably can imagine, the core abstractions of when you go to Starbucks is that you want to order something, and unfortunately you have to pay for it, right? So there's two different aspects of the or business slices of business functionality, and yeah, so one is ordering. That's very straightforward. You want to just place an order. You have products, probably drinks, and a lot of options that you can configure on them. And then you have to trigger some payment. The entire process, is it what we're going to? Okay, looks something like this. So if you arrive at Starbucks, you go ahead and place an order, right? So you arrive at the counter and say, okay, I want to order, what I usually take is some grande Java chip, no whipped cream. And what that actually creates, or that's the way they modeled in the book, is that you create an order that's in a specific state, in the state of payment expected, right? And as long as the order is in payment expected, you can do a few things to it. You can update it, so I can decide whether I want whipped cream or not, or I can even go ahead and cancel it. Say, okay, sorry, forgot my credit card, no cash whatsoever, I gotta go. Once I paid it, it gets prepared. That's not really the way Starbucks works, right? That's slightly idealized, but let's just take this as an example of, okay, there's a state transition that's actually triggering some long-running background process, right? So we pay, that's state transition 4. We pay for the drink or for our order, and that kicks off some background job, usually some dude or gal running and preparing the drink. And we now walk over to the other counter and wait for the drink to be prepared. Once that's done, someone is just coming to the other counter shouting grande Java chip for Ollie, and then I just take it. And what we model here to conclude the order is a dedicated step to take the drink, right? So something that really will conclude the order, otherwise it stays in, okay, can be rejected or stuff like that. We could get more complex in here as well. But just let's keep that ordering process as an example, because it already contains quite a few interesting things to discuss, and especially things that are worth looking at from an implementation point of view, right? So you will see all of that being implemented and how this is working with the Spring stuff. So I read the book. I found the example interesting. They have an sample implementation in JAX RS, I think. And it turned out that in that book, they created a lot of helper code that was preparing or making a few implementation side of things easier. So they created a link abstraction. They had resource model or representation model classes that you could equip with links. And implementing a few REST web services for customers as well, we saw the very same patterns emerge each and everywhere. And that's why we started to build a tiny library that I will introduce to you as well, called Spring HATEOAS, in case you haven't. Has anyone heard of Spring HATEOAS? Okay. What are you here for then? Okay. So what I've done then is on my quite a few plane rides, I spent some time at airports, and I thought, okay, why not just go ahead and try to implement the very same thing using Spring technologies, because there's some helpful stuff out there. There's Spring Data REST. Back in the days, there was no Spring HATEOAS then, but stuff from the reference application went into the library as well. So it's essentially an implementation of the stuff you have in the book, and yeah, it's available on GitHub, I think. Is it? Yeah. So there's this bit.ly link. It's just in my github.com/Oliver-Gierke/Spring RESTBucks, and this is what we're going to dive into in a bit, and then partly we'll rebuild from bottom to top, actually. So the current version, attention, I changed that code quite drastically sometimes, but the current implementation is using Spring Framework 4.0 I'm not sure they have it announced yet, but it's been out or in the repos for a week already. I've upgraded the Spring Data implementation to 1.4.1, which is the Babbage release, which we just announced today. And there's the Spring Data REST project I'll go into, and Spring HATEOAS in 0.8. So pretty much the latest versions. You see there are snapshots of Spring Data REST because we're doing a major revision there. It's coming up, and there's some neat features in there. Okay. This diagram, I hope you can read that in the back, is pretty much our exploration map for the next 60, 70 minutes, or even more. It's a PowerPoint architecture diagram for how the application is structured. Most importantly, we have, as I've indicated before, we have two separate business functionality parts, vertical slices. We have the orders, and we have the payment going on. You will see that reflected in different packages, and I've separated those because, okay, just a system with only the orders would be somewhat usable or reasonable, just to keep track of the orders. We don't have to have them or allow the orders to be paid theoretically, but you can separate it. You can draw a line there, as I did. And the more important reason to separate the stuff is that the payment process is essentially the process that we've modeled before, right? So it requires a lot of manual implementation, whereas the order stuff can almost completely be implemented in quotation marks, because there's nothing really to implement by using Spring Data REST and Spring Data, and I'll show you that. So we leverage the two projects, in this case Spring Data JPA and Spring Data REST, to easily build a REST endpoint to manage orders, to place them and to delete them and update them, just using those technologies. So there's, especially for the web part, there's no manual code that we need to write for that. The payment process is like the upper right corner. I'll probably just take the other one. Where is it? There it is. The upper right corner is essentially the web part for the payment stuff, and there is a bit of manual implementation code, and you see this slight shade here in reaching into the Spring Data REST box. We will go ahead and customize Spring Data REST, or link into the stuff that Spring Data REST will produce for us to extend it, and then plug our payment subsystem into the defaults that Spring Data REST provides. Service layer will be implemented manually. There's just a fake preparation engine in there that just receives the payment and then sleeps for 5 seconds or 20 seconds and then says, okay, drink prepared. So pretty much close to what a Starbucks employee usually does, right? Just kidding. But the foundation for that will be Spring Data repositories as well. And I've left them in black as well because there's close to no implementation code necessary. But if you know Spring Data repositories, you're already aware of that. So I gotta go this way then. Okay, so let's have a look from on the code base from just the outside. I hope you guys can read that in the back. Is that readable? That code in the back? Does it work? Okay, because it just feels like I forgot my glasses and it's blowing up this screen here, but it's important that you can read it. All right, so there is Spring RESTBucks. Here's the app. That's already the training code. Go ahead. RESTBucks. So what is Spring RESTBucks? At its core, it's a Maven application. Just using, or it's a Servlet 3 Spring 4 web application, which is embodied that in the fact that there's no XML whatsoever in the application, so no persistence XML, no application context XML, nothing. The only thing we have here, so we use JavaContig. Let's try to do that. There's a bit of stuff going on. We will go into that bit by bit, but we configure some infrastructure here, JPA setup, which you can actually get rid of when you use Spring Boot. Unfortunately, I haven't found the time to migrate the code base onto Spring Boot yet, but essentially what's here can be defaulted by Spring Boot. I guess you'll have been in a session of Dave already. If not, just have a look at it, but that's the way it is if you just wrote it manually. And I mentioned the Servlet 3.0 spec, which can be integrated or can be triggered by just extending that abstract annotation config dispatcher servlet initializer. It's got some rhythm to it, right? And you're probably used to Spring class names. Have you ever seen that one here? Has this type pattern tried to sneak in some? It's a favorite of mine. I have to show it in every presentation. Guess who wrote it? Who? Right. You win as many washing machines as you can bear. So, all right. So this is essentially a Java way of replacing the web XML with some indirection through the Spring framework. So you've defined a context loader listener and the application config files, and you can just say, okay, this is my application config here, and there's a web configuration class here, and I do the root servlet binding to / and there's a little bit of other stuff, fancy stuff going on. But that's essentially it, right? In there, I zoom in a bit for you to see the packages. I have a core package, which just contains abstract entity. That's just a base class for JPA entities. Monetary amount in terms of, just to have something to reflect monetary amounts. I could have used Joda money for that, but I just didn't want to add yet another dependency. And there is the order subsystem, and it has just a domain model. There's an order for, where is it, order? Yeah, there's an order. Zoom out here again. So we have drinks for takeaway or in store. We have a status, which is where you see payment expected, paid, preparing, ready, taken. You see they roughly reflect to the state transitions that we actually saw before already, right? There's a size, nothing really fancy. There is an order repository, which is a Spring Data repository. For those of you who don't know, I keep it short. The way the Spring Data repositories work is just you create an interface for your aggregate root, in this case the order, extend some Spring Data base repository interface, in this case we do paging and sorting repository, and then you write methods into it, just like this one here, find by status, and this will then you activate the Spring Data repositories in your Spring configuration, and that will automatically create a proxy for that interface so that you can call this method at runtime, and it will do the right thing, TM. Right? So order has a status field, as you've seen. So in the case of JPA, we actually generate a not a JPQL query, but a criteria query that is equivalent to select O from order O, where O.status equals $1. Right? So automatic query generation, you can tweak that stuff quite a lot, but the bottom line is for simple query execution, you don't need to write any execution code anymore. The same goes for like simple CRUD methods, like if you go into that stuff, you see there's find one, there's save, and all that stuff is what you get out of the box with just dropping the interface there. Pretty cute, I think. All right, so the order repository, there is a bit of web stuff going on. There's the payment subsystem, and I probably just show it to you running. RESTBucks, try that one. May even jelly run. That's the easiest way to get it running, hopefully. So what it now does is it runs the application, it finds the web application initializer, bootstraps the web application, bootstraps Hibernate, Spring Data repositories, and activates Spring Data REST, as you will see in a second, which means that it's creating some bindings for the repositories. So do you remember I've bound the application to just /, right? So let's see what that does. Localhost 8080. So we have a few links here. So we get back a resource. So that thing is rendered by Spring Data REST. Actually, let me just quickly show you how I activate Spring Data REST, because it's just a single line of code. There is this web configuration thing saying add import repository REST MVC configuration. What that does is you bootstrap your application context, and it contains quite a few Spring Data repositories, probably. And it goes ahead, finds these repositories, and then creates REST resources that expose the repository for you to just trigger HTTP requests against it. So you find the orders here, and you see, you find in this content element here, you find two orders in here that are just rendered as JSON. Right? So by default, we do some Jackson marshalling here, and you already see there are some kind of links in here, right? That we will look into what they actually mean and why they are there. And due to the fact that order repository, where was it? Extended paging and sorting repository, that means you can walk through the list of orders on a page-by-page basis. You get some page meta information here. Okay, by default, we just return 20 elements. We have 2 elements in total, a single page. And what you can now do is restrict the elements to be returned through. I don't know if you've seen that up there. So I've added page 0. Pages are 0 indexed. First page by a page size of 1. And what that does, it just renders the first order, of course, right? It tells you, okay, there are 2 elements there. Probably hard to read for you in the back. 2 elements there. But even more importantly, it generates the next link. Next and prev are like standardized link relations for you to just browse through to the next page. And if you go to the next page and you've reached the end page here, you get the previous link. Right? So that's just out of the box by placing that interface here. Where is it? And let it extend paging and sorting repository. That just works. Another thing that we do by default is that we expose resources for each of the query methods that you've added here. Right? You see that find by status method. You have a searches exposed, and you have the find by status search exposed, and you can go ahead, and if you don't have anything in, you just don't get anything back. And then I go and say payment expected, and I find all the orders that are in status of payment expected, which are 2. Right? So that already gives us quite a lot of stuff that we would have to implement manually. It's a quite sophisticated rendering mechanism in terms of that it uses links to point to related entities if there are also repositories available, or it embeds them if they are not available. And yeah, so you basically go ahead, just place your entity, place your repository, activate Spring Data REST, and get a fully fledged REST endpoint in there. Right? So this is the default stuff we get. You see here, if I go here, you see that here are quite a lot of links in there, and we will have a look at the reason the links appear there. But these links are actually domain specific, right? So we've designed our REST web service to be to allow us to cancel the order if it's in the payment expected state. So that's not something Spring Data REST renders by default, of course, because that's related to our problem domain. It's not something you would get. What you would get by default is the self link anyway, so that you know, okay, this is the order that you can essentially go to, right? So that's just okay, access the single order. All right. Okay, just a web app that you can play with and explore, which is what we're going to do in the next 60 minutes. We gotta be quick. Yeah, go ahead.
Is there a reason you chose to put links in a separate section rather than using like entity expansion or something like that?
Entity expansion, how do you mean?
Well, in other words, if you say you have a book resource and there's an author resource, instead of putting the author in a separate link section, kind of like the how+JSON stuff is, which is kind of what you're doing.
Yeah.
You instead just have an author with an href, and then when you request it, you can choose to expand that entity, so they can say, _expand equals author, and then you get some summary information within that. So it's like a complex object within. I'm trying to be fast. Sorry.
Yeah. So what I think this boils to is, okay, how do you design your JSON representations, and how do you decide what to link to and what to embed, and what format to choose for embedding and linking and stuff?
Well, it's a specific question about the choice made here to do linking in a separate section versus.
Okay, we actually what you've seen here. Let me go back to orders. Oh, I killed it. Too bad. So there was content, and there was for collection resources there was content, and there were links. So we decided for that format I think the decision was made 1.5 years ago when the project started, and none of the hypermedia representation types that were out there, like HAL and stuff, were like, okay, there was no real view of which one would get more prominent and which one would succeed if there's something like a battle there. So we just went with that one, and to separate the links out so that you can easily find them, right? Because if you just want to look for links, if you just flatten them out into the actual domain object, that's never really clear whether this is from the key of the map. You can't really tell whether it's a link or whether it's a real value. So that's why we went with that one so far. But I mean, we can go into detail of that with offline or after the talk, then, if you want to.
I have a question.
Yeah.
So with REST, you're supposed to treat the URLs as resources, not actions. So in the rel, though, you're calling it cancel and update, which is an action.
Yeah. So that's what I did, didn't I? So let me reboot it in the back. There was no verb whatsoever in the URI. Search? Yeah, it's a search.
I guess it's also
Well, yeah, okay. The important part of that is, I get that asked quite a lot, okay, what about verbs and URIs and stuff? The important part is not, it could be just, let me go ahead, it could be just, do that and say plus plus plus. What about /food or /bar? What about that URI? Is that RESTful?
Only bar is an ID.
I'd argue you cannot tell from a URI itself whether it's RESTful or not, because if it behaves according to get, put, post, delete, it just doesn't matter what the URI looks like, right? It could be something like just slash and then do some hex value in here, right? Right, that's it. So the important part, and that's what I get into in a second, is that the client knows the rels, and the rels can be whatever they want, right? So just actually let's go and look into that, because we've seen that. No, okay. I probably do that part quite quickly, as I've explained quite a bit of that already. So the Spring Data projects are there to accommodate or build some common ground for, or programming model for interacting with different stores and make it easy for you to switch from a relational store to another store, not doing that for a single application, but just mentally coming from one project, seeing, okay, this is working with Mongo, and this one's working with JPA, and there's not a big difference in the programming model. There's, of course, differences in the implementation details, but similarly to Hibernate, where you of course have to know JDBC, you can mitigate some of the differences of the stores in there. The key part of it is the repository abstraction, which you've just seen in action. I think I skipped this lab because we're probably just wasting time on that one. In case you're interested in that kind of stuff, there's a session tomorrow that Thomas and me are going to do on Spring Data repositories and stuff. So also with JPA best practices around that stuff. So there we go. That's just the foundation, so it's easy to do a data access for you in whatever store technology you'd like to do. Spring Data REST is essentially building on top of the Spring Data repositories. Up until version 1.1, we had milestone 1 for that one still. The repositories had to be CRUD repositories, for those of you familiar with the internals a bit. We've changed that for 2.0, so you can just use arbitrarily repository interfaces, and they will work. The REST project essentially goes ahead and takes your domain model and your repositories and creates CRUD REST endpoints for them. Not entirely CRUD only, because it does some kind of the hypermedia stuff in terms of linking resources and assigning resources through hypermedia already. But what you should be aware of is, okay, we will expose resources. These resources can be identified, and they have a uniform interface. So the IDs of a resource are URIs, as the name suggests, and there's a well-known set of verbs that we can interact with the resources: get, put, post, delete, options, head, trace, what have you. We never interact with the resource itself, but through a representation. And this is where the fun part starts, because that leaks into the ladder, into the hypermedia thing, because there's difference of ways to design representations for your resources. And depending on which way you go, the last part, the hypermedia part, becomes a bit more complicated or gets easier, or yeah, we'll look into that in a second. So what is this hypermedia thing? There's this abbreviation, HATEOAS. Is that the correct way you pronounce it here? HATEOAS. Adios. That sounds rather Spanish, doesn't it? So Ben Hale actually did the right thing. Okay, there's no real pronunciation for it. There's rumors that Roy Fielding just invented that abbreviation to start having people discussions around the pronunciation, so that they get into the field. But it essentially means that you equip your representations, or you use the representations that you deliver not only to transfer data, but also include process information or navigation information into the representations. And I will get asked quite often for examples of hypermedia-driven REST web services and the clients for those. And I say, okay, the first one, the best example I can think of is Amazon.com, and the best client I can think of is your browser. Because if you think of an ordinary web page, or a web page like Amazon.com, as a REST web service, that chooses HTML as its representation format, you see that, okay, we're not only including data and presentation information to some degree, but you also include links. And you as a human find these links by just searching for the titles of the links, like the stuff in between the A elements. You identify the links, and you make sense of them, and then you follow the links, right? You probably, if I tell you, just look for the Spring Data book on Amazon.com, you probably don't go ahead and try to say, okay, Amazon.com/book/spring-data-book, go, right? You don't know that URI. You just go to Amazon.com, you find a form that actually says, okay, here's something you can do with the resource, you can interact with it, you can execute a search, okay, you pipe in Spring Data, you get back a list of results, and then you follow the link because you just recognize the link pointing to the resource you're interested in and follow the link. So you don't know the links up front, your client doesn't know any of the links up front. All it knows is, okay, there's a representation format, how do I display it so that the user actually can make sense of the links between the resources, which is by presenting the titles of the links, right? Or just hiding them behind button images or what have you. So, that still feels a bit awkward, and only little people are satisfied with that answer, yeah? But it's essentially the very same model that you can apply to machine-to-machine interaction if it comes to hypermedia REST web services. So there are a few implementation patterns. Give me a second, just let me finish that one. I'll be back with you. There are a few patterns that have emerged that I've seen through a lot of customer projects, and that felt like I was repeating the same code over and over again. So you're exposing a resource per aggregate route. You usually implement get, put, post, delete for them, for the very basic stuff. You have links between the resources, so assume you have an order that links to the products it contains of, or the line items of the order link to the product it consists of. That's the right word. And you have to think about, okay, which media type do I want to use? Do I want to use JSON? Do I want to use XML, HTML, what have you? Especially the latter is quite a box that if you open that up and discuss the different options here, yeah, you could probably spend 2 more sessions on that, on only that one. We will briefly look into that as well. Okay, Spring Data REST essentially implements these basic patterns, and we take the repositories, go ahead and expose them to the web, and hand some configuration model to you that allows you to tweak and have control over what gets exposed, in what way the resources get rendered, and also to modify the representations on the fly, which is kind of useful, as you will see in a bit. Yeah, that's essentially it. Do we do that as runtime, as a lab? I think we should. We can just briefly skim through that stuff. I'm not going to implement it entirely, but so that would be the REST-1 project. Maybe some infrastructure remark here. If you import the projects as Maven projects, just as I did, you can just go to the just activate the markers view down here, right? And then you see all the to-dos that I've put in here, and you can step by step walk through the stuff and actually get it to work, right? So there's a bit of, if you jump to that one, I don't think I'm going to do that, but you see here, okay, remove the abstract thing, and then there's a few methods to comment in, so that you see that what will actually trigger that Spring Data REST is running. But yeah, I just skipped this for now because it's just from code from a training that people would want to maybe explore later on or stuff. So this is a part of, or this is close to the Spring RESTBucks sample here. We have the critical part. I think I already showed you that. We extend the base class for the web initializer, and then the critical part is here saying, okay, repository REST MVC configuration, right? So that's it. What is probably quite interesting here, I want to plug that in real quick, is, okay, how do we now generate a REST web server, we generate in terms of, okay, we produce one at runtime out of the box. How do you test that stuff actually really works? And who of you has used the Spring MVC integration testing facilities yet? Only a few. So then that's probably quite interesting for you. So what we've decided, or the way that people usually test these kinds of applications, and we will actually implement a client for our REST web service in the form of a test case later on, is that people went ahead and modified their build scripts to bootstrap a Jetty or Tomcat right before the integration tests run, and then use like a REST template or something to trigger requests to their web application. That works, it's fine, but that has a lot of side effects, because in every environment that you now run, you have to find a port or make sure that the port that Jetty or Tomcat will run on is free, is available. And you essentially have two JVMs running, the test JVM and the app JVM, and there's a network in between, which actually doesn't have to be there, right? So what we've tried with the Spring MVC test context framework, which is part of Spring 3.1, oh no, it's 3.2, I think, is that we can actually go ahead and bootstrap the application in process, and it leverages the Spring test framework so that the stuff gets cached, and it just looks something like this. If you have used anyone used the Spring test context framework for integration tests already? Okay, quite a few more people. If you guys develop Spring applications, how do you do that if not through this way, right? So you usually go ahead and say, okay, I want to run my test case with this Spring JUnit runner. Then you can define, I'd use a context hierarchy here, but that doesn't have to be a hierarchy. Just context configuration says, okay, please bootstrap this configuration as an application context. And then you go ahead and, where is the order resource integration test? It's here. Then you go ahead and auto-wire components from your application context into the test class, right? And the test context framework will take care of not having to rebootstrap the context each and every time, and just auto-wire the dependencies into your test class before the test method runs. So what we're doing here is the basic setup for the Spring MVC web testing. So as you've seen here, we use a web app configuration annotation that says, okay, this is going to be a Spring MVC integration test, right? Which causes the application context being created to be a web application context so that we can actually inject it into the test class. And what you then do usually is that you build a mock MVC environment using this builder API. Does that work again? Sorry. There we go. Through this builder API, from this context, you can add servlet API artifacts to that mock MVC, like we do with the shallow ETAG header filter, which we see in a second, and the open entity manager in viewFilter, and there's a JSON parser going on here as well. But you finally end up with a mock MVC. And what you then do is actually the testing definition part. You say, okay, I want to perform a GET request to /. You see, no host, no port whatsoever. It's just in process. We perform the GET request, and we expect the status to be okay. We expect the content type to be returned, and there's a JSON path helper method here that allows us to run the JSON path expression, which is close to XPath. That thing here essentially reads, find the href attribute of the links inside links. So find the link with the rel order, and then get me the href attribute of that one. Right. So it essentially goes ahead and says that should fail actually because it should be orders. Let me try to run that. Does that work? Okay. Great. Yay. There we go. Okay. So you've seen the application being bootstrapped here. There is some pageable resolver. This is actually Spring Data REST in action already. So we are binding the Spring Data REST controllers to some mapping here, and then execute the test method like this here. If I run, just for you to see that again, it was REST2, right? Maven Jetty run. Just for you to see what we're testing. Oh, I could have used the other thing as well. It's essentially accessing the root resource and then looking up the link with rel orders there. That's essentially it. And we will see in a bit how you can use that testing framework to really extensively test what your server-side REST web service does. So let me check. That should be done in a second. Okay, so the XPath expression essentially goes ahead and says, okay, from within the links element, we look for the rels and we take the href attribute for the one of orders. So that thing will get returned in this case. And I just check for it not being null, so essentially for the link being present, right? So that's link is present. That's essentially it. All right. Cool. That's the other thing. Web integration test, activating the rest. We had essentially that. Okay. Now up to the fun part. I initially just walked you through this kind of process modeling and the state transition modeling essentially. And the question now is, okay, how do we actually design this kind of process as a hypermedia-based workflow, right? So if we just took it from scratch and we're using a non-hypermedia approach, we would probably end up with a reference documentation, something like this. We would document which URIs we use, so /orders, or you can post to /orders, and that would actually create a new order, and that is essentially step one here, right? We can use post or patch for partial updates on the individual order. But you see here, okay, we have this little clause in here. This is only allowed, as you've seen here. Go back. This is only allowed, this is the second, the update essentially, if we're in this payment expected date. So we have to find some means to prevent that when the order is in a different state, right? Okay, go ahead. There we go. So there's a lot of other stuff going on. So yeah, the preparation, the paying triggers the preparation, and yeah, there's this taking of the receipt. So that's straightforward, and that's already something because we've used the HTTP verbs correctly. We don't have any nouns in our URIs, if that matters, any verbs in our URIs, if that matters, and we have essentially an action for every state transition, right? So what are the challenges with that? The first and quite important thing is that we hard code the URIs. So we will have people that, similarly to my sample that I told you before, saying, okay, when you want to look up a book at Amazon, you go ahead and try to construct the URI, right? There will be clients that know, there is some pattern of /orders / something, and that will get me an order. And so they will go ahead and happily reconstruct our order pattern into actual our URI pattern into actual URIs. Now, what if we decide that /orders is not really the name we want to go forward with, but change it into /foobar because that's more nerdy, and you want to do it, and all of a sudden you break all of the clients out there because they still continue to go /orders / something. What about adding new URIs to your representation, right? So you go ahead and document them. And it's very hard for clients to adapt these kinds of changes. So you pretty much, if you document a REST web service like this, you pretty much give the URI space out of control. It's set in stone as of the point you've released it. Set in stone in terms of you will be breaking clients if you change something with it. Okay, so what do you do about it? It's essentially link relations, which means that we introduce some kind of indirection and tell the client or define link relations, which can happily represent actions or state transitions for the resources. What the text doesn't really matter. So we define, okay, whenever you find a link that is named orders, you can access orders under the link, under the UI, whatever it looks like, and you can post to it to create a new order. That's essentially the semantic definition. Plus, we of course define, okay, what payload do we expect? Usually with a tiny sample payload or what have you. If you really care about specs or stuff, you can go JSON schema, XSD, whatever. But usually it's just a sample payload that does the trick. There's a self thing. The order identifies an individual order. Self is the resource itself. Cancel we have for the cancellation of the link. There's update, there's payment, there's receipt. So it's essentially a rel for each state transition. And now we come from this and go to something like this. Magic. There we go. This essentially frees the client from knowing about the URIs because it will only use the rels to find the links inside the representations, right? Just as we as humans use or can make sense of the text between the anchor tags in HTML, a client will be able to make sense of, there's an update thing going on. So I can just use that URI to post or patch to, right? Of course, it has to know these up front. And if I introduce a new rel for my rep service, the old client won't be able to use it. That's fine. But the old client still can use the other ones and will still continue to work. Just the example I gave here is assume we introduce some kind of bonus card functionality, and before paying, you have the possibility to swipe or post some customer ID information so that you get some credit points on your bonus card or something. Then you could just add a new link, say, okay, this is bonus card, rel bonus card, and if you have a new client that can leverage that, it would just be able to trigger that or follow that link before triggering the actual payment. And that's the way people usually evolve APIs. They're not changing the semantics of existing rels, but introduce new rels to add new functionality to the project. Of course, you can deprecate some rels and remove them later, but that's usually the safe way. Okay, just adding new stuff. Okay. The funny part about the stuff we've defined here is that we have some constraints about the client to be allowed to trigger certain state transitions only if the order is in a certain state. So by allow, I mean, okay, how can we restrict a good client, a good citizen client, to only invoke the state transitions when it's allowed? And the idea here is to define that the client can only follow links that are currently present in the representation. So just modeling our payment process from scratch, it would go just something like this. The client gets a single URI encoded into its code, hard coded. Say okay, my restbucks.com, what have you, and it does a GET request to it, and it gets a resource back or representation back that contains the list of available resources. And it now sees, oh, there is an orders link in there, which I know when I find this orders thing, so the upper orders thing, if I find that, I can follow it and I can get all orders there, or I can post to it to create a new resource. What this thing down here looks like is totally uninteresting, right? So the client would then assume we want to order like a coffee or something. We access the root resource, we find the orders link using that JSON path expression, and then we, as a client, know we can post to it, we know the representation, and then we just go ahead and do so. We find that link, that green link here, and then post our representation to it, and this is what we get back in return. And here, this is actually the interesting part. What you get back here is not only the data, like what did I order a cappuccino? That's not what I order usually. But it's $4.20 and it's in payment expected. That can be used for some UI or something to display it. But the interesting bits and pieces for the client are, okay, what rels do show up in the links section here? So it says, okay, I can cancel, I can update the order, and I can pay it, and that's what I want to do here, right? So the link is present, I can follow it, which leads me to I trigger the payment. We again find the link. We know that under the rel payment, we do a put request to trigger the payment, and we essentially go ahead, find the link, go ahead, and that results in a response like this, saying, okay, here's my famous credit card. For some reasons, a lot of people are using these. So it's running out very soon. So it's in €4.20. Okay, I'm sorry about that. But I get the data alongside the a few links. Okay, here I find the order that is connected to the payment, and this is if I want to look at the payment later on, I can do so under this URI here, right? Whatever it looks. You could argue that the client already knows, or it doesn't already know about the order. Oh, did it? Give me a second. Yeah, so the client knows about the order already, so he could just have remembered that this particular order is under that URI. Just remember it in terms of store it, keep it somewhere, cache it, and then from the payment to return to that order, just use the cached value, right? So I usually get asked whether if I have an API like this, doesn't that mean that a client always has to go to the root resource and then traverse each and every step from that root resource? Of course, it does not. Have you guys played Command and Conquer? Yeah, some of you? You know that kind of black map which you have in the first place, where you don't know anything about the terrain that's around you, and once you go somewhere, you find the places and you know, okay, this stuff is there, and you essentially remember it, and you can, of course, reuse that information, cache it. Because if it gets invalidated, if the order's not present anymore, I mean, you get 404, you get 3 something for redirects or what have you. So it's not really a problem to hit a URI not existing anymore. Go ahead.
How do you recommend the TTL for that cache? Just per session or for the client? How long should the client cache?
That highly depends on what you model and your business purposes. So the orders probably will stick around forever, so it can just remember that order. I mean, assume we're writing an iPhone client, then it's just, okay, the orders that I've placed anyway, there's absolutely no problem in keeping track of them locally on the client, or just entirely. Yeah? Yeah.
you don't go and construct the URI, right? You go to the index, try to search, go to catalogs, find the book, right?
Mhm.
But then the user can also bookmark it, right?
Yeah.
So if he starts in like level 3 in, you know,
Right.
transition, then how is the hypermedia model gonna
So, so the question was, okay, one aspect I find interesting about your statement is, okay, if we get back to the Amazon example that I had, you can of course bookmark the URI for a book, right? That's essentially just caching the URI for it. And if the URI changes, then Amazon will issue a redirect to something, right, later on. And the question was, how do I reconstruct the state, or how do I get into the state?
the client doesn't necessarily come through the index to all the
Right, so if you access the URI directly, how do I express the state? We get into that in a second, right? Because what we now actually do after we've triggered the payment, do you remember that actually triggers the preparation process on the server side? Which means, okay, what do we do now? So we get back to the order resource, we follow the order link, and we get into a state where there are no links in there, except, so we find the orders link, and we find no link except the else link, which essentially means, okay, the order is either done, which is not because it's in preparing state, or yeah, it is in preparing state, which is at most or essentially indicated through the missing of links here. So even if you just bookmark that thing and return to it later on, which is essentially what polling to some degree is, right? You would see the state reflected, because if we poll now, at some point the order will be prepared, and that will cause the next request to find the order in the new state. Okay? Does that answer the question to some degree? Okay, then let's try to have it later on, right? Okay. So there are a few things that I think I put on that slide that you might want to consider here. So in HTTP, in plain HTTP, polling is the only or best option to get informed of resource changes. There are people arguing you could use something like WebSockets, but you're pretty much leaving the REST space then. There's a lot of techniques to reduce the overhead that the polling introduces. One of them is using e-tags and an if-non-match header. So saying, okay, I do a request. Alongside the representation, I get back a hash value. And for the next request, I say, only give me the representation if the hash is different than what I sent you, right? So that would still require the server side to compute the representation, but not send it back. So you save the network traffic essentially. Or that's the way I've implemented it in RESTBucks, because I wanted to go simple. You can, of course, have a more sophisticated implementation of that, just detecting, okay, the resource is still in its state without pulling it from the database through some kind of caching mechanism in a Redis or something. But that's it here. Also, you probably don't want to go ahead and query or poll every 5 seconds, but rather dynamically increase the waiting time between the polls, right? But just highly depends on how often the resources actually change state. Okay, there's one here. I'm a bit torn here. Okay, so we poll the order, we use caching on the server side, we use the if-non-match headers. We will see that implemented in the test case in a bit. And we poll as so long until we find the receipt link in here. You remember that was the very last step. We can actually access the receipt by following the receipt link, and then conclude the order by triggering a delete request, right? So the core point that you should take from here is that the client, and at no point in time the client knew any other URI than the root URI in the first place, right? It just used the link relations to identify links and followed those, given on a certain spec that has been implemented somewhere. All right. What is? Yeah, let me just check. Okay. The question is, are there any client-side libraries? And the answer is yes, there is. The most prominent example that I heard of is REST.js in the QJO. I think it's the QJO project that we also lead. I think Scott and Jeremy are working on that. So it's a project led by SpringSource. That is essentially a REST client that allows you to plug in interceptors that then go ahead and say, okay, there's a MIME interceptor where you can say, okay, I have a special hypermedia format, just as HAL. Have you heard of HAL? That's like a definition of how you represent links in JSON. That's essentially it. So how you find them, how you represent them. And then you can say, okay, you can use the JavaScript library to say, find me the link with the order rel. And it returns you a link instance. And then you can just transparently grab that and use that for your next request. Right? It's also something I show you on the server side or for the Java side in a second. Because I was looking into means to implement that style of REST web services in the Java world, and it turns out that there wasn't so much support for it. The JAX-RS spec has, the Java specification for REST web services has the word link 2 times in its specification. I did a quick search on it. So the first one was in the Oracle law disclaimer, 4 pages long. And the second one was in the glossar, explaining what a link is, but no support whatsoever. The most recent version, JAX-RS 2.1, has added a link builder API, something similar, so that you can point to JAX-RS resources, and it will allow you to build links from the annotations, the mapping annotations. That's kind of cute. We have a slightly advanced version of that in the project I just showed to you, called Spring HATEOAS, which we built because Spring MVC was lacking this kind of support as well. So we have really decent support for URI mapping, for content negotiation, all that stuff that you want to have. But if it comes to, okay, how do I create a link pointing to my orders? You usually keep up with URI mappings kept in constants and then reusing them all over the place. But I'll show you how that works with Spring HATEOAS actually. Yeah. So what has Spring HATEOAS? It has representation models, so simple model classes that you can use to, okay, here's my customer. I put it into my representation model and I add 4 links to it. There's a decent API for that. Simple as that. The question is, how do you create these links? There's a link builder API that allows you to express, here is my controller method. Please give me the link to that controller method, a link object. Very easy, I'll show you in a bit. Representation enrichment is something I go into later on. How much time have I left? 20 minutes, okay, that's cool. What do I demo? Let me quickly check. I have a demo for that. I just have to find it. Sheesh. There should be a window working set. Spring HATEOAS. I missed that. There should be a HATEOAS sample. Yeah. So what you can essentially do, that's also can be found in my GitHub repo. What that lets you do is, let me go ahead. That's a bit too complicated already. Yeah, that's fine. Just take that as an example, and that's the API actually. Where is it? What's a good sample here? Let me go ahead. Okay, I go with the order resource. Order resource is, I'm using Lombok here in case you're wondering. That's just a tiny helper compiler plugin to generate a lot of useful stuff like getters for that and a constructor for the class. But the real interesting thing here is, okay, there's this resource support class, and the resource support class, I can move to it, is the base class for all our representation models. It is just a class that has a list of links. So a link object essentially there's quite a bit of stuff in there. It has a rel and a href. So it's a container for something alongside links, right? And what we now go ahead is say, okay, our order resource is essentially that link container plus a list of line items. That's it. And the way we use it is we just take our domain object here and use the line items to wrap them in the order resource. And then, this is probably the more interesting part, I have to scroll like hell in here, is we can create a link object by using that API here, saying link to method on order controller. And that call here returns an order controller proxy. It's not a proxy, it's just some dummy order controller that you can actually invoke a method on. And that's that part here. So go with that part. So we get back. Have you worked with is it Mockito? Anyone worked with Mockito already? EasyMock or something? Then you probably know this kind of pattern. You record fake invocations just to find out, okay, what you've done to the controller, not to really invoke the method, right? So we use this thing here. Here we get back an order controller. We fake invoke the show order method, and then use the parameters that you piped into the method to reverse, not really reverse engineer, but to reverse engineer the URI that you want to create with that, right? Because you've defined the mapping here. The variable is on the request side of things. It's actually pulled out of the URI and bound into this place, and on the link building side of things, we just use the value that you pipe in here to expand that URI template here. So whenever you do this, you see it in a bed. Where was it? That doesn't work. Customer controller. There we go. Where was it? Up here, down here, there. Right. So for all the orders that we find here, we take the order ID and add a link to order / something. And this is completely type safe here. No strings, whatever is going into, and yeah. So just use those here. There's more advanced APIs, even if you've probably briefly seen that annotation up here, exposes resource for customer. There's also an API that even allows you to say, I want to create a link that points to the resource that exposes customers. I don't care which controller it is, what have you. Right? You can do that with the Entity Links API, but that's probably something you can look into yourself. That's it. We support a variety of hypermedia formats, where a variety means two. So far, we have quite a few requests for others, but the ones we support out of the box is the format with the JSON format with content and links, which you saw before, and the other one is HAL, and we're really inclined to move towards HAL because it seems to evolve into some kind of the standard JSON hypermedia format. There's an interesting aspect actually that most of the people were banning XML because they were fed up with it because it's verbose, it's slow, and pretty much everyone was going to get back onto JSON for data exchange. And then all of a sudden people realized, in JSON we have to solve quite a few of the problems that something like HTML, for example, has already solved for us. The way you represent links in the representation, right? If you just use HTML as the representation for your data, then you get A's for free, A's with href and titles in there. And in the JSON space, you have a variety of standards that compete there, the way you represent links, the way you represent collection resources. There's collection JSON, there's HAL, there's quite a few others. But yeah, you can just, with a flip switch in the configuration, I think it should be, give me a sec. I probably just quickly find it. With a flip switch in the configuration, you can go ahead and say, okay, please don't render the content and the link thing, but rather render it in HAL which means do we go there? I have these classes 5 or 3 times. There we go. Enable hypermedia support is in here, and then you go with type equals hypermedia type hal, and that causes all of the JSON stuff be rendered as underscore links and with embedded resources and whatnot. So
Allow for custom media types?
nope, not yet. We're going to change that slightly, because right now you define one hypermedia type you want to support, and we probably move that towards the HTTP message body converters, HTTP message converters that we have, so that it will actually be driven by the content negotiation. So when you use application JSON plus hal, you would get it this way, and if you use application collection plus JSON, then you would get it separate. And then it's just a matter of implementing your custom HTTP message converter and registering your own media type, and then off you go. Question?
Agendal supports post methods in RESTful API, right? So how do we enable, like, if you are using app, how do we enable post methods to be communicated to the client?
Post methods communicated to the client.
Yeah, so for example, to post an order, right?
Yeah.
To an order, you have to pass this methods, this.
Yeah, you just probably document it somewhere and just have a sample payload in there.
And the client has to hard code it, right?
Yeah, of course. The client has to know the rels, and it has to know the data formats in whatever way you want to communicate it. For hal, there's even, I'm not sure, I find it quickly, Mike Kelly wrote this cool thing called, is it the hal browser? Okay. No internet for me. But for hal, it's essentially, there's this notion of link currying, where in the links section, you have a curry element, and that says, okay, you prefix all the links with something colon, and everything that's prefixed with something colon can be turned into a URI based on some URI template. So you would, let's say, myapp/rels/ template placeholder, so that you can then look up the definition of what that rel needs, which HTTP method it supports under that URI. And given that, he has built an application, and I think it's just a Ruby application, that would just you point it to your REST web application, and it will present you in a UI, so that you can essentially move your way through the API and look up the documentation. And it will, yeah. It's called hal browser, I think. So if you Google for it, very cool stuff. So, whoa, we're running out of time here, guys. Miscellaneous REST shell, Spring Data REST. I've got that. So what I would like to do now is just to give you, in the last 10 minutes, give you a run through the extension points that we use to implement the payment process in the web application, right, in RESTBucks. Because so far we've seen the order endpoint. For the order, the orders are completely managed by Spring Data REST, and we have 2 constraints to them. We can only update them if they are in the payment expected state, and we can only cancel them in the payment expected state. To achieve that, Spring Data REST has an eventing mechanism built in, which allows you to get notified when it receives a request to delete something, to find something, to update something, so that you can essentially implement what I have here as the core, no, it's not the core order, the order controller event listener. You just extend abstract repository event listener for order. And that essentially means you get is it that one? Where is the other one? Yeah, okay. It's only partially implemented, as I see now. Okay, so you get this on before delete method from the event listener, and you get the order handed into the method before it's trying to be deleted, right? And what we now do is just use our domain model to find out, okay, the order is already paid, so we cannot delete it anymore, right? That's essentially it. And that's what Spring Data REST will then invoke, and this way you can prevent certain actions to happen. You can trigger other stuff. I mean, it's a Spring component here. Can you just do anything that you want? Core order resource process. Right. Okay. Give me just a second to finish that. From the order side of things, during the payment expected state, we want to add the cancel and the update links for the client so that the client sees the links and can follow them if needed. And what we do here is we implement a so-called resource processor. That's essentially a component that gets invoked every time resource gets, or before the resource gets rendered. So what we say here is we are interested in the rendering of a order resource, and before that rendering happens, please call this process method here, right? And this is what we do. We look up the order from the resource, and then if the order is not paid, we add a few links here. We say, okay, we'd like to have a link to that individual order. That's the Entity Links API. I didn't go into too detailed, but say, okay, with the cancel rel. This essentially creates wherever order is handled, and adds a rel for cancel and adds a rel for update. So let me just in the back, so that I can show you that stuff, run it. This is the cancel and update links here, right? Excuse me? We'll be at the payment in a second. There was another question over there.
So if I happen to write a hypermedia-based RESTful application,
Yeah.
I should use the Spring HATEOAS, which is coming in Spring 4, correct?
Right. So there's the Spring Data REST thing is okay if you have the Spring Data repositories and want to expose them quickly. If you just have your plain Spring MVC application that is building REST web services and you want to add the hypermedia elements, links, representations, what have you, Spring HATEOAS is the way to go. So it's the additional library. It's 10 classes or something. It just provides you that API, and you can use that from a plain Spring MVC controller.
And the RESTweb application that you just now demoed, is it available on the GitHub?
Yes, it is.
What's the URL for that?
github.com/Oliver Gierke/Spring RESTBucks. If you just Google for it, it'll be the first hit. The links are also in the slides that I will upload later, and that's it. So what about the payment stuff, right? That's a good question. Because we want to expose a special payment resource that can be triggered. So we want to implement the payment stuff ourselves, right? So we say the base mapping is request mapping orders/ID. And the first thing we implement is, okay, receiving the payment for an order, right? So we pull out the order that's just plain Spring MVC, yeah? The mapping here is go ahead /payment. So it's order/ID/payment on the server side, that's fine. So we trigger the payment, we get a credit card payment back, and we create a payment resource that has a link to the order we've just paid. Fine, okay? We show the receipt because that's related to the payment. That's also in here. And there's the payment, the receipt deletion, so essentially the conclusion of the order. And there's a credit helper method in here. Fine, okay. That's essentially, I mean, there's quite a lot of business logic behind it with, that's in here. There is this payment service that does credit card checks and what have you. There's an aspect triggering the asynchronous preparation of the event. I can show you that if you like. There's the engine. That's a message listener essentially, and it marks the repository, the order as in progress, sleeps for 5 seconds, and then marks the order as prepared. That's essentially it. We'll see that in a second being used. The interesting question is, so we implement our payment functionality completely separate of the order web functionality, and the question is now, we have to sneak in a link to the payment stuff we have into the order when it gets rendered, right? So whenever an order gets rendered and it's in the payment expected state, add a link to the payment subsystem. And that's done by the payment subsystem providing a resource processor that has exactly that code in there. So it says we are interested, from the payment subsystem, we are interested in renderings of orders. So that's what this thing here says. Gosh, come on. There we go. Where is it? There. So resource processor for resource of order. And then we say, okay, give me the order. If the order is not paid, add the payment link. And if it's ready, add the receipt link. There's just like an indirection here for entity links, get single resource / payment, what have you. Just to have a single place for that. Nothing fancy. So that's essentially it. Payment links, payment web. There's a bit of, of course, implementation code for domain objects, for credit card number and what have you. So something for you to play with, right? Shouldn't be too simple. The interesting thing is, okay, let's just build the 3 minutes left, damn it. I just run the integration test for that, and I leave it to look up the integration test to you. What I've done here is I've just I broke down the test into the individual steps that we've modeled in the first place. So create a new order, trigger payment, poll until the order has a receipt link, and then take a receipt. And that thing now is using the Spring MVC integration test framework to do exactly that, right? So from the root resource, we find the orders rel, we find the link with the orders rel, we take that link, whatever it looks like, we load this JSON thing here, and then trigger a post request to the link that we found and make sure we get 201 created back and a location header. And if we found the location header, we take the location header and perform a get of the location to wherever the location points to, right? This covers order resource, access first order. Let me just run it so that we can conclude the talk by just running through the logs real quick, because it's kind of interesting to see the polling happening, and then we're done. I thought, okay, there it's going up. Let me just, where is that? Lock it. Okay, so you see the app bootstrapping here. We're accessing the root resource. There's some Hibernate output there. We found a link. We accessed. There's no log output for the order being created, but we've created the third order, as you can see here, and there is a payment link in there. We've discovered that payment link pointing to something, and then we trigger the payment. Which on the server side, there's this payment aspect going on here, publish the event that the order is paid, and then which the engine actually receives and kicks off to process the order, which means sleeps for 5 seconds. During that time, we first go ahead and make sure that once we've paid the order, we cannot delete it anymore. This is here trying to a cancel request and making sure we get, I don't know what, I think it's method not allowed or something, getting that back. And then we pull the order. The first call we do is we receive a 200 with an E tag, and going forward we do if non-match requests and get back 304 with the same E tag, and then on the server side the processing of the order is done, which changes the state of the order into ready, which causes our next call to be returned with 200 and a different E tag. You see those two are different. And then we find the receipt link and take the receipt, and then we're done. Right? There should be some final order state. Okay. That's essentially it. All right. So I think that's a lot of stuff for you to play with. I have a couple of resources for you. There is, if you're interested in the Spring Data project, into deeper stuff in there, there will be a talk tomorrow at 10:30. And there's also a multi-client development talk with Spring by Josh, who's also having a REST stack kind of thing with going much more into security and what have you, OAuth, and what all the stuff you need for REST web service. If there's questions, I'd be happy to answer them probably after most of you have gone out. Or if you find me at the conference, we'll be here until the end of the week anyway. So thank you very much for your attention, and glad to see you. Thanks.